if an engine is putting out high levels of CO, he may get a headache, or he may, his eyes may burn, or he may develop a cough or a sore throat due to higher emissions.
Oh, I've experienced not only the burning of the eyes and the emission smells.
I've been in some heavy CO and I'm sure heavy NO and NO2. And on longwall moves, you're setting shields, you're staying right in it 8 hours a day.
Overfueling would put more emissions and unspent fuel in the atmosphere.
If you see black smoke coming out of an engine, it's operating inefficiently. It's running too rich. It has too much fuel.
Diesel particulate has been identified as a health issue.
Diesel particulate matter levels, when controls are in place, are very low.
If I got black smoke on the machine, that means I'm getting too much fuel or no air.
Certainly it's going to take a much more vigorous maintenance program to comply with the regulation. It's going to take a much more vigorous testing scenario. We have to know and ensure that they're running properly. We're going to have filters that plug prematurely, and that gets expensive, when you're changing out filters more often than you should have. And so the only way to mitigate that is to ensure that we do good maintenance.
When an engine is tested for MSHA approval, it's tested at sea level or slightly above sea level. One of the primary things during that test is to establish what the emissions, both gaseous and particulate, the engine is putting out. And from that evaluation, a ventilation rate is established to provide the necessary health protection for miners.
At this laboratory, we can test diesel engines over the entire operating conditions that the engine would see in a mine environment, and we can simulate a variety of altitudes that the diesel engine could potentially be used in a mine. The approval process also involves testing one of these engines in a laboratory condition where it's instrumented to measure the gaseous emissions that come out of the exhaust. We instrument it for surface temperatures if it's a permissible engine. We measure all its performance parameters to verify that the engine they specified is actually how it performs. The engine that's submitted for approval is an engine that is representative of all the engines of that particular model number.
The engine is operated throughout its operational range to determine what the maximum CO level and maximum NOx that the engine will produce, to establish what the maximum fuel-air ratio for that engine should be. And from that evaluation, a ventilation rate is established to provide the necessary health protection for miners.
All the information is collected as far as the test data, and all the drawings, all the pertinent drawings for that particular engine are processed and put into the package, and then a certification or approval is awarded to the manufacturer for that particular model engine.
When an engine or a machine with an engine arrives at your mine, you have to make sure that that engine is properly adjusted for your altitude. And an authorized representative of the engine manufacturer has that information, and they can make those necessary adjustments. So deration means you have to cut back the fuel to match the available air. So you're going to lose power even if you didn't make an adjustment. If you adjust the fuel for the altitude, you're going to operate the engine much more efficiently. And you're going to lose some horsepower, but you're not going to produce excessive CO and particulate matter and smoke. So as you go up in altitude, you have to cut back on your fuel to keep that ratio between fuel and air the same. So the emissions which a miner experiences at a low elevation, providing him with the necessary protection needed for health, that emission level of both gases and particulate remains the same for a miner operating at a higher altitude.
We'll have to learn to live with the deration. We're just swapping our health for a little bit of time and horsepower, and that's what we're swapping for.
And any time that you take a machine that's 150 horsepower and you derate it at this elevation to where you're getting down in the upper 70s to 80 horsepower, it's pretty tough to make that machine where it's still a viable machine.
At first there was some reluctancy because the equipment run a little different. And our good operators caught on to it right now. And they said, we can still perform work with this vehicle. And they learned how to make it perform. And I think that was the key, is the operators would find out what they needed to do to get the same performance out of the vehicle, and they could do that.
When you go to that fuel rack setting that's mandated by the regulation, it really makes the machines, it derates them to the point where they won't do the work that we need. So we've had to find other ways to compensate for that. For example, on our IMCO trucks, we've installed superchargers. And of course, we're able to bring some of that power back and again, have a machine that will accomplish what we need to have done.
Anytime you adjust fuel ratios on diesel engines, you sacrifice power and horsepower, but that's something we could deal with gearing and gear ratios and that kind of thing. And it's something we're willing to do for the benefits that we get from it.
We try to take this fleet of 320 vehicles and make them run as efficient as we possibly can. And that's not just including emissions. What we look at is the best emissions we can get, put the absolute most amount of power we can get on the ground, and get our best fuel economy out of the vehicle, longest engine life, things like this. It's all tied together, and we monitor this with the diesel emissions output from our weekly tests. We didn't know what good was. Our fleet average at that time, first week of the testing in '97, was 1,597 parts per million CO, 997 NOx.
As far as maintaining the equipment and that, before you start, I would do all the pre-ops, drain and flush your scrubbers, make sure your scrubber shuts down when it runs out of water, check your fillers, your intake manifolds and all that for leaks, and just watch and clean it up. You know, if you got a problem, fix it.
If my CO levels are up, the first thing I would check would be my flame arresters and filters. If that didn't cure it, then we'll have to go a lot deeper.
If you see an increase, if it's substantial increase in CO, that equipment needs to be pulled out of service, and there needs to be some checks made to see why. Everything that's on the checklist that we go through is right out of the manufacturer's manual. You name it, we check it.
Okay, we make sure the engine will shut down on the emergency shutdown. We check the gaps on the lights, oil level checks, fuel leaks, accumulations on the machine, tires, lug nuts, park brake. We've got a checklist we have to go by.
We check the emissions end of the machine. We check basically the whole machine from top to bottom to make sure that it's maintained right.
The weekly examination takes in the gaseous emissions part plus the permissibility safety part of it.
The baseline we're using now started in January, so we have the emission samples from every week this year, and we have an average which gives us a baseline. If our weekly CO is 20% above our baseline, we will take immediate action to find out why. Right now, our CO average is 230 parts per million CO. Since we started doing weekly tests, I've noticed a big improvement on the upkeep of our equipment and a very big improvement in the emissions output of our equipment.
You need the same people doing the tests every week. You don't have to specify the same guy per piece of equipment, but you need the same people doing this consistently every week. The output on the diesel emissions is going to tell you a lot more on the operation of that engine than anything else. What's the engine temperature? What's the exhaust gas temperature? We're going to be here before we stamp the test. That's when you get consistency, and when you start getting consistency, that's when you can make all the numbers go down. I have engines right now that are running 8 to 12,000 hours on them, and the weekly emissions on them are almost identical to the day they were born. Now, in 1997, our average engine in a permissible application was rebuilt between 3,000 and 3,500. Our engines now are going 8 to 12,000.
You know, we can clean the air up better. It would be better all the way around for everybody.
The pollutants are going to be cleaned up.
The mine environment in this mine has improved greatly the last couple of years.
No doubt about it. The emissions are a lot cleaner than what they used to be.
The atmosphere is definitely a lot cleaner and a lot better than it was 20 years ago when I first started in here.
Help keep people living longer.
It certainly does clean up the air, and it makes us a healthier place for our people to work.
You know, I think we have a cleaner environment underground than we once had.
A clean running machine is always better.
You know, all the guys underground, you know, I'd like to consider were my friends. And you know, you want to provide them with the best atmosphere you can.
Hopefully this program will eventually get us there. I don't think we're there yet. I think we've got a long ways to go as an industry as well as a company. But the ultimate objective, of course, is just to get ourselves to a point where our employees are working in the safest environment we can provide.
All engines must be approved, and it's important to maintain established ventilation rates. An authorized representative will derate your engines for your mine's altitude. Engines should be properly adjusted and maintained. Conduct weekly emissions tests to establish a baseline for each piece of equipment, and maintain consistency for your testing program. For more information, go to www.msha.gov.